Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 386 lexicographical numbers. So given an integer n, return all the numbers in the range 1 to n sorted in lexicographical order. You must write an algorithm that runs in big of n times and uses big of 1 extra space. So there is no extra space constant, and we have to find out this, generate this array by linear time big of n. So there is actually for this example one, there's n is equal to 13. So what is the if n is equal to 13, then what is the number actually 1 to n? Means 1 to in this actually equal to 13, right? So I have to generate an array of this from this number 1 to 13, which actually sorted in lexicographical order. Now, how actually what is the lexicographical order actually in number? Is actually lexicographical means the dictionary order, like 1 will come before 2, 2 will come before 3 in this way, and now 1 then it will become actually 10, then 2, then 20, then 3, then 30 in this way, right? Like in dictionary order actually no, right? In the dictionary actually like A, then AA, then actually A B, A C, A D, in this way A Z, right? Then actually it comes actually B, then B A, suppose in this way B B. Similarly for this number also, like first digit actually 1, so whatever the number, so 1 actually is smallest digit possible at the first index, first digit can be possible as minimum is 1. Now if the first whichever number is starting from 1, that will actually come before whichever the number starting with 2. So all 1 will come before whatever the 2 actually, after the 2 will come all the numbers that is starting with 2. Now in 1 actually what is the condition, that whichever actually come first, the smallest 1 will come first, then it will come actually 1 0, then if it is 100 then it will represent 100, then 100, suppose this is a range, so 101 will come in this way. Now 101 actually completed, suppose, or n is equal to till 101, so I print 101, then what will come 1 1, then 1 2, 1 3 in this way, right? Till this actually possible 19 in this way, right? From n is equal to, if it 101, then this will be the our box or all the numbers that actually starting with 1. And what is the order for this? First it will start with 1, then 10, then 100, then it will print 1000 is out of bound, so it will not print 1000, so it will come actually just increment by 1 actually, 1001, 1002 if it is, but it's already 1001, limit is 1001, 101, sorry. So it is actually print till 101, then actually break, then what will be the next actually smallest is 110 as previously, it will be 11, 12, 13, 14, in this section 19, right? So this is the lexicographical order. Now if I have to generate all numbers from n is equal to 13, like 1 to 13, so what is actually first observation? Actually just check, like first what I have to print, I will print 1, then 10, then 100, then 1000, then 10,000 in this way, right? Then what will print, I will print, suppose our limit was actually 105, so what then I will print till here, actually I will print. Then next what I have to print, next I have to print actually 101, 102, 103, 104, 105, right? Now I have to reach the limit, so it will break. After break, what will actually print, I'll print this actually. After that 10 I have already printed. Now next I will print actually 11, then 12, 13, 14, 15, 16, 17, 18, 19, right? Can I print 20? No, because this is actually starting with, this will start with 2, that actually not in the range, right? So I break from here, then any other things are actually left. Next is actually 1, next number is, if I go to the next number 2, that is not our range, not is that is not starting with our current digit 1. So I'll break from this. I have completed all the numbers in lexicographical that is starting with 1. Then I'll start from 2. Okay, then 2 for what? 2, 20, 200, but 200 is out of bound actually, 105. So I'll not print here actually. Okay, so after 20, what actually print? I'll print 21, 22, 23, 24, 25, 26, right, 27, 28, 29, in this way. Now if I again increase by 1, this will 30. 30 is actually starting with 3, it is not starting with 2, so I'll actually break from this. Again I'll go to the actually next number is previous number is 2. 2 next number is 3. If I increase by 1 actually, so that actually not actually starting with starting with 2 digit, so this is actually break. So next I'm starting with all the number that is starting from 3. Again similar approach. Now what actually you are doing actually to get the lexicographical order? So first of all, like, find out all the numbers starting with 1, right? First, whenever we get any number, this will actually answer. Okay, so I'll store this 1 into our answer. Next, what are we're trying to insert? 1 0, right? So this is actually the answer currently after sorting. You can also check. Now current number I actually have 10. So what is the next smallest number? 100. So this is also in the range, n is equal to 105. So I'll store this 100 into our answer. Next is 100, 1000, 1000. So this is out of bound, so I will break from this. So I will not continue here. Okay. So next actually what will happen? 101. Okay. Because at the 10 I actually appended 0 here, and I have already explored all the number that is starting with this depth. Now I will check. I will append 1 actually here. Okay, I'll check. Okay, this actually in the range. So I'll insert. I'll store this into our answer vector. Next, then I will go to the again depth 1010. This is actually out of bound, so I will not explore. I will return from this. Next, I will insert 110, 102. 102 is actually our actually in the range, so I will store this into our answer. And I'll go to the next depth. I will actually try to push again 0. This is out of bound, so I will actually return from this. Next, I will try 103. This is actually in the range, so I will store this and go to the next. Next is 1030. This is out of bound, so I'll just return from this. And next is 104. In this actually, I'll actually how many actually digits are possible to add? Like here actually, I can actually add 100, 0 to 9, like 1000, 100, 101, 102. In this 109. So I can actually append only 1 digit. So this is actually range. I can actually generate this number, this many number, 100 to 109, right? And at the next depth, actually I can generate 1000. If I already taken 100 numbers, so I'll generate 1000 to 1009, right? And if I take the this 101, then I can generate 1010 to 1019. But the next number, if I take this 1020 to 1029, in this I can generate actually, you can check all the numbers actually you are actually generating, right? So to get the sorting order, lexicographical order, what should you do? First, insert 1, then go to the next depth, insert again 1 means 0, 0 to 9 actually. Okay, again go to the actually next depth, again actually insert 0 to 9, then go to the next depth, again insert 0 to 9. In this actually till the depth we actually hit on our range, just store that number into our answer vector, because this actually give us the smallest number, because starting with the smallest digit, because the prefix number will be smaller, right, compared to the whenever we go to the right side. Like first we explore with the all the digit that is starting with 1, then I will go to the number that is starting with 2. In this actually will start number 9. So 9, whatever the digit starting with 9, it will come later actually, right? So that's why we will whenever so smaller number will come first, because we are exploiting the big lexicographical greater number at the end actually. right? So just go to actually code DFS actually help us here actually how. So this is actually a result vector that I have to return, and whatever digit can start with 1 to 9, because first digit can't be 0, like we can't actually any number 0 1, right? So this is ultimately actually 1, so that's why for the first digit the range is actually 1 to 9, first digit. So I am calling the DFS function by passing the current number I, and this is a limit, and this is a result vector that I will store the number, and ultimately I will return the result vector. Okay, so what does the DFS function do actually? So this actually I will get the current number, suppose 1. So this actually I will check this current number is if it is out of the range actually n, if it is greater than n, that means I can store this number, and I do not need to actually check the greater number also starting with this number. Like if our range actually suppose actually 4, okay, 4, and our current number actually 5. So do I need to check with 4? No. And we don't need to check also 50 also, 50, 500 also, because this already actually greater than this already exceeding the current number, our limit. So this number will always greater than this, so we do not need to check that actually. So that's why if whenever our current number is greater than n, just return from that. Else this number actually our range, so I will store this into our result vector. Okay, now what is the next step? Suppose this is a current number 1. Okay, then what is the next number will be 10, then next number will be 100. Then how it's generating? So what is the range of this digit? 0 to 9. From the second position on, from the second digit, first digit can only be 1 to 9, but from the second, third, so on, actually that digit will be, range will be 0 to 9. I can place 0 in the right side, but we can't start 0 with a digit with a number with 0. That's why now our range is 0 to 9. So I'll just try to push actually 10 here. Okay, then check if the current number is greater than n, that means break. Current number means like our input is 1. So if I actually trying to convert this 10, that means what? 1 into 10 plus 0, right? This will give us a 10. And if I want to actually make actually 11, suppose I want to make actually 11, then what is actually 11? 11 ultimately is 1 into 10 into 1, whatever the input, plus 1, the digit value, the current value. So that's why I is equal to 0, I less than equal to 9, I plus plus. So what I do, I will check if the current number means the input into 10 plus I. If I insert if this is a range less than equal to n, that means this I can actually store this. If it is greater than n, that means what? We can't actually store this, and we are actually exceeding our limit. So just break from that. Else our current number is actually within the range. So I'll just call again the DFS function where I'm passing what? 10. Because you can check current into 10, this is actually current actually 1, and 10 plus I is equal to 0, and n is equal to constant and result vector. So this is ultimately calling this function again 10, n and result vector. Okay, now our input is actually 10. I will check this is actually 10 less than equal to n, less than equal to n. So I will store this. If it is greater than n, that means break from here, return from here. Else I will store this. Okay, this is our range, so I will store this into our answer vector. First it will store 1, then I will currently store 2 at 10. Now what is the next number? Next smallest number? 100, right? So I'll come here actually for this for loop, and what actually I try to assign 0. So I will multiply this 10 into 10 plus add 0. So this will give us 100. Got it? So I'll check this is your range. Okay, I call this DFS function again recursively. Just go to the next if it is possible. If it is not possible, then break from here actually and go to the next. Next is possible is 101. So how can actually I go to 101? 10 into 10 plus 1. This actually I, this one. So in this actually I can generate 101. In this actually I will generate all the numbers. This is lexicographical order. So in this actually we're actually only calling this DFS function big of n times, because there is actually n numbers are possible from 1 to n. We're not calling any same number repeatedly, right? So this is the DFS approach. Now there is a mathematical logic also in mathematics actually we can actually do this. How? So suppose starting number is always 1, right? Then what actually the next number possible? 10, then 100, then 1000, right? Suppose our limit is 105. So first I will print 1, I will just multiply 1, then I will just multiply with 10, then I will get 10, then I will multiply this 100, right? If I again multiply this 1000 10, then I will get 1000. That actually out of bound because our range is actually 105, so I can't print this 1000 number. Now what is the next possible? Next possible number is 101, then 102, 103, 104 and 105, right? This is the possible number, so I can print actually. Now how actually you are printing this? Now here actually you are multiplying with 10, here also you multiply with 10. Now here actually you are adding plus 1, here also you are adding plus 1, here also I am adding plus 1, here also I am pressing plus 1, here also adding plus 1. Now what is the condition when I am multiplying? First I have to multiply this 10 till we are not exceeding our limit, right? Like 1, 10, 100. Okay, now 1000, whenever we go to the 1000, it is exceeding the limit, just break from, because we can't print that. Now we will come to this plus 1 condition till it's not reaching 109, next 9, right? We can print, or also we are not actually reaching the which was smaller, like 105, this is a limit, or 109, right? Because if we print 110, this is actually the next cycle actually it will come, right? So that's why first try to multiply with 10 till you're not reaching the exceeding our range limit. Then whenever limit, then plus 1 actually it will actually play the role till you are not reaching the limit. Limit means 105 or the 109, right? Now what is actually what actually we should print after 105? 105 we have printed till 105. Now next what actually we have to print? I have to print 11, right? Then 12, then 13, 14, 15, 16, 17, 18, 19, till 19. Again the last digit is 9, not 9 or in the limit, which is smaller, because here actually 19 actually smaller than 105, so that's why I stopped here actually after 19. Now how actually we actually converted, jump from 105 to 11? How? Even check, we actually continues it from 100. Now what is the previous number before that? 10. How actually get the 10? We actually started with 109. We suppose stopped from 105, stopped at 105, right? Now we have to start from 11. How actually I can go to actually jump 105 to 11? You can check, if I actually divide this by 10, what actually I will get? I will get actually 100, 10, 10, right? This I will get 10, right? So this is actually the previous base number actually starting from 10. You can check actually this is 10 and we are also now starting from 10 actually. So I got the actually previous number that is starting with this. Means I have actually discarded the last digit, because we have actually appended this, this 0, 1, 2, right? So just discard this, just divide this by 10. So I got this 2 digit. Now I'll start to increase plus 1 by this from this number. Got it? That's why I'm printing 11, 12, 13. In this again I actually printed 19. Now actually I printed this. Now actually I have to go to the actually jump from this. So 19 by 10. What will I get? I'll get 1. Right? Now I will just increase by again. I'll get by 1. I'll get actually 2. Next actually what number actually I have to print? 2 actually. Whichever the actually digit starting from 2 actually. Now I'll print 2, then 20, 2000, 200. So this is actually already exceeding the limit, so I will not print this. I'll stop from here and I will just print 20 again, 20, 21, 22 in this way. Got it? So just go to code, then it will be easy. So our current number starting from 1, always it will be 1, and this is the answer vector that I have to return, and I will store the number in this vector. So how many number are possible? 1 to n number are possible, because we will generate 1 to n, and I will, whatever the current number, I will store this into the answer vector. So first I will store 1 here in the answer vector, right? Then I will then what is the next target? Try to multiply this 10. I'll check if I multiply this with 10 and it is within our range, within a limit less than equal to n. That means I can actually store this. If it is less than equal to n, then I will actually multiply this, right? So current will be now 10. Now I'll come to again. I'll store this 10 here actually. Okay. N is equal to suppose 105. Now again I will come to this if block. Current is currently 10 and I will try to multiply this 10. If this less than equal to n, less than equal to 105, yes. So I will actually store this current will be now modified to 100, right? And again I will come to this for loop and I will store this current and 100 is stored. Now I'll try to again multiply this 10. Is this less than equal to 105? No. So it will come to else if. Else if what? Now our plus increment will come. How many actually till how much actually till what is the condition? I can actually increase by 1 till we are not reaching actually last digit in 9. So that's why what are the last digit modulo of what is the current number? Current number actually 100 modulo of 10. What will it will give? It will return actually 0. If it is not equal to 9, that means what? I can actually increase by 1. And if I increase by 1, it should be on the range within our limit. So 100, I will try 101 less than equal to 105. Yes, this is actually true. So I will actually increase this by 1. So current will be currently 101. Okay. Now go to the again for loop body. So answer will store 101 now. So I will come here actually again 101 into 10. This is out of bound. So again come to else if. I'll check the last digit 1, and if I not 9, so I will increase by 1. So this is 102. So I'll check, okay, 102. This is actually within the range. So I will increase this. So current will be now 102. Again I will come. I will store actually 102. In this way, suppose I reach actually 105. Okay. Now I'll come to currently actually 105. I will try to multiply first 10. That is not actually not our range. So I will come to this else if. Else if what? 105 modulo of 10, that is not 9. Okay, this is true. But if I increase by 1, 106, that actually less than n? No. So I will come to else block, right? Else block is what? I'll current by 10. Current by 10. What? Current is 105. So 105 by 10. Then modulo of 10. That means what? 105 by 10. This will return actually a 10 modulo of 10. That will return actually 0. If it is not 9, that means if it is 9, that means we go to the left in this way. Like discard this, like this is the number 199. Okay. Then what is actually next number? Next starting number? 200 is not possible because 200 is starting with 2. So next starting number is starting from 1. So what is the next possible number? Next possible number is first divide by 10. It will return this 19, right? Then find out the modulo of 10. This is actually 9. So this is actually true. So again divide by this 10. So this will actually return 19. Now again check 19 by 10. Modulo of 10. 19 by 10 means what? 1. 1 modulo of 10. This is return 1. Okay. So this will actually starting with 19 now. So current will be now here for this 105. The current will be actually 105 by 10 modulo of 10. This will return 10 modulo of 10 0. So this actually break. So it will come here. Current will be now current by 10. So current will be, current was 105 by 10 plus 1. That means 10 plus 1, it will be 11. You can check actually, find the base number, that is not actually 9. Right, so it will actually starting from now actually, current actually now pointing to 11. You can check here actually, now current actually set to 11 from 105. You can, if you don't understand, if it is not clear till now, you can actually try this in by your own copy and try to the how actually its current is setting to 11, where current is actually 105. Got it? Now why actually we are doing this while loop here actually, like for 199. Okay, so what is actually next number actually, next possible starting number can be. So this digit already I actually I can't increase this. Okay, because if it increases then 200 is starting with a number 2. That is not actually lexicographical order, good order, but it can be, but we have to check that is there any number left or not with starting 1, right? So first check with the 19. Okay, I'll check with the 19. Is there, can I start with 19 again? No. If I start with 19, then it will actually increase the count. If we increase the count, then it will be 20 actually again. That actually again same number starting with digit 2. That is not actually true. Then, and we have already explored, like even suppose we actually stop here actually 19. Then what is the number actually? You can start 19, 190, 1900. That we have already explored. That's why we print actually 199, right? So that's why till actually we are actually not reaching any digit. That's actually not 9. Like here actually we reached 1 ultimately, right? We reached 1, and what have to do? 1 into 1 plus increase by 1. This you check, we increase by 1. Got it? So this actually we increased by 1. Now it is pointing to 2. So we're actually now we will start all the number that is starting from 2. Got it? We have already completed all the number that is starting from 1. Like it is clear, right? So here also your time velocity is big of n, because we are iterating each for loop, this for loop big of n times only. So that's the time velocity big of n. And here also this is constant, like if block there is only else block, there is no while loop also here there, but this is digit, length of the digit, because this is actually maximum digit length of the any number. And now it's we are increasing current, returning the answer vector. So time velocity is big of n, and space complexity is big of 1, because we are only using this answer vector that we have to anyway return, anyways I have to return. So if you have any doubt, or if you like the explanation, please like the video, and if any doubt you can actually comment on that, and please share the channel with your friends who actually benefit from this actually. Thank you.